there are more than 3 that we could get into, but I think for doing the kind of analysis that I've been showing you examples of, there are 3 main issues which seem to me to be the most important things to think about. The first is uncertainty in the actual data value. So we've measured a certain set of materials represented by these black dots in the yellow circle, and this uncertainty is about whether the answer should be, say, 6 or 7. What's the actual uncertainty in the numerical data value? That uncertainty might come from methodological issues, like if it's based on survey samples, there might be some error and uncertainty in that. We might not be sure how to convert between units, like in the timber example, you have to convert tons to cubic meters often, and it might be unclear what the moisture content of the timber is. But that's relatively straightforward to understand, I think. What's harder is to deal with uncertainty about the definitions or the scopes. So here, the comparison is between saying these 5 types of material account for 6 megatons, as opposed to maybe these other 3 should have been included as well. So that's not about the numerical number, it's about what's included in that number. And then the final type is that sometimes we don't have direct measurements for the process that we're interested in or for the quantity that we're interested in. So we often end up relying on proxy data, less so for these kind of production quantities because you wouldn't necessarily expect them to be the same. But if you're talking about yields and efficiencies and losses, we would often make assumptions that those are similar between different countries or between different plants, and there's uncertainty that comes from that. So for the first type, or the data value uncertainty, I think
Sorry, Rick, you've got about 1 minute.
Yep, that's fine. I'll wrap up. We've got different methods that we can use for modeling, so Monte Carlo analysis, uncertainty propagation. The key thing is that we need to be able to understand how much uncertainty there is in the data values that are reported. So anything that people reporting data and surveys can do to estimate the uncertainty in their figures is very helpful for the modeling. For the proxy issue, there are some issues there like the pedigree matrix that's used in life cycle assessment that can help you to think about the different reasons why some data might be better or worse than some other data when you're using it in a different application. And the third type for uncertainty about the definitions, I think there are different kind of tools that can be used to formalize those definitions, but it doesn't really matter exactly how you do it. All we can do to reduce that uncertainty is to, one way or another, be as explicit as possible about defining and explaining what is actually included in each category or material type that's being reported. So, to conclude, talked about modeling material flows and given you some examples. And I think in the work that I see, I guess possibly it's different if you're in a position to develop some of these things new, which is really exciting. We're often relying on data sets that are developed for other purposes. So there can be some of the issues that I showed you. Unnecessary detail is not a big problem, but unclear categories, things that are not reported, and data that's undisclosed for confidentiality are a big problem. And I think it's important that we consider uncertainty, and it helps to do that if we can estimate uncertainty in data being reported and be as clear as possible about the definitions of what the data is actually telling us. So I'll stop there. Thank you.
Thank you so much. Colleagues, if you have one clarification question, I'll take that now, and we can have more detailed questions later on as well. There isn't one, that's okay. I have a bunch, but I'll save them for later. All right. Then I will move on with our next speaker and then leave a lot of room for questions after this. So the next speaker is Dr. Nathanael Otávio Favero Bolzon. He's from Brazil, so he needs a special pronunciation. He's currently a fellow at the University of Birmingham, And before this, he did his postdoc at the University of Cambridge in our group, where he looked at mapping energy and material flows for efficient resource use in the foundation industries. It was in this Transfire project. And his background is analysis of energy systems towards sustainable development. He did his PhD in energy resources and petroleum engineering, and a master's as well in mechanical engineering at KAUST, which is King Abdullah University of Science and Technology. And before that, he did his undergrad in Brazil, Federal University of Pampa. Nat, the floor is yours.
Thank you, Carla. Let me share here. Can you see the slides all right? All right.
Yes.
Thank you, Carla, for the introduction. So today I'll be presenting about the project that I worked during my postdoc at Cambridge. That was the Transfire, and especially showing like the resource flows in the foundational industries. So to give some feedback of the Transfire, like at Cambridge, we are working like looking to transfer the best practice for the foundational industries. When I'm referring to the foundational industries, it's usually referring to the 6 main sectors like cement, chemical, ceramics, metals, glass, and paper. So it's just like the bulk materials that we use most like for infrastructure and to manufacture everything. And the idea that we have like here with Transfire, like really to map these resource flows, to understand where we are today, like in terms of like these linear wasteful systems, what are material and energy consumed, which products we are manufacturing, and what is the waste generated. So to be able for the next step, that will be like, how can we improve efficiency? How can we reduce energy and material consumption? Also try to see if we could add circularity to these systems and still provide the same products. And once we maximize this efficiency, like what is the transformation needed in the sectors? Like how could we reduce energy, materials, get rid of emissions, have circularity, and reduce the quantity of products to deliver the same amount of products, reduce the quantity of products to deliver the same amount of services that our society needs. But today I'm really going to focus on how we can map where we are today, what are the energy and material flows, products, and waste. And once we start to see how we are going to build this, the figure of where today, one of the first questions that we have, like how to visualize these resource interactions. Because we want to combine energy, material flows, and emissions in one single diagram. So how we have like all these combinations in terms of visualization, you still have like an informative figure, like we can get all the required information to be able also to extract metrics from that. And one thing that was very important for us, even because of the nature of the project, is because of the versatility. Like it should be useful across different sectors and scale. So as I mentioned, like we showed that we are covering like 6 very different sectors. And also you want to build an approach that allows us to use it from a company level to national level, even to global level. And also maybe if you want to measure like from annual average or instantaneous, it would work. So like want different time frames also. Our approach was really focused on the industry. So like you are focused on the sectoral for the UK. So like the 6 sectors at the UK level. And mostly like you are mapping energy and material inputs and try to have clarity in terms of outputs, products, byproducts, emissions, required energy, and also heat losses. But once we go in detail, what do we want to map? So in terms of material inputs is like all the materials that are used during this process. For example, like raw materials, you can consider like limestone for cement, recovered material like slag. In terms of material outputs, what is the product like cement, byproduct, for example, dust. Sorry, this map is really focused on the cement production, so this is used to illustrate. And also to be able, sometimes like we try to get these mass flows, you see that they are not balanced. or also what we call invisible flows, things that are usually not reported by the industry. You don't find them on statistical data, and sometimes when you are looking to the production line, you see that there are disbalance, like the most common ones are air and oxygen flows, like they are never reported. Also, water is another one. That's this kind of other inputs that is really hard to find information. And in terms of also understand the emissions, like what are the emissions coming from reactions, what is coming from fuels, and also water vapor, depending on the fuel that you are consuming. And in terms of energy inputs, we are trying to get map all the carriers from coal to electricity, and also how the energy is leaving the system. Like if this energy is used and locked in the materials, like part of the chemical reaction, so transform these materials, if it's just lost or if it's recovered or sold. So here is kind of a summary of the approach that we implemented. You can see like here on the top, we have all the material flows with the material inputs on the left. Are you seeing my pointer? Or no? Maybe no.
Yes, we can.
So like you can see here the material inputs on the left, the material outputs in terms of product and byproduct. Here in the middle of the graph, we have like the emissions associated. So like you can see that from reactions, fuels, and the water vapor, this water vapor is very simple approach, just have like the balance. And one thing that I want to emphasize in terms of energy inputs, because sometimes you just have like the energy coming from the fuels, but also we got the mass equivalent of these fuels consumed. So like you are able to estimate all the emissions associated and have and keep the mass balance. If not, like you see that one of the main issues with emissions, while from the process you have all the material inputs is easy to estimate, usually you just have like the energy flows of energy, and it will be unbalanced from a mass perspective. And also in terms of energy, when possible, we always try to get information like, okay, what are the chemical reactions? Like how this energy is being, let's say, locked to convert, to transform this material, and understand what is the grade of the heat that is leaving the system, because it's a high grade heat, medium grade, or low grade. So like this is kind of like the temperature of the heat that's leaving the system. Why that's important? Because maybe you can see if it's feasible to have like a symbiosis to recover this energy, or that's really lost. There's no use for that heat. Another point that's not covered here, but it's important to know, is like how this heat is leaving the system, because it's very different to recover heat from a hot airflow and recover heat from a solid steel bar that is blowing hot. So like it's quite hard to recover. And sometimes you get issues, for example, like if you think about glass. Glass is a material that has a very specific cooling rate. So you cannot really try to extract, because this is going to you break like the glass, so it will not work. So just to give like some practical example, we can start like looking for the steel sector for the UK. So you can see here at the top of the Sankey diagram, we have like all the material inputs. You see all the raw materials. Also, you can see the share of recovered materials. This is scrap steel. And you can see the main products and byproducts. So here, like I just separate between steel and steel alloy, and you have like the amount of slag. And also you can see all the emissions associated with this conversion of like reduction of iron ore. So you can see here you have like a very clear mass balance. Now if you focus in the middle of the Sankey diagram, we have the emissions. So like you have the mass equivalent of the fuels consumed, the fuel emissions associated, and also I just keep for reference the emissions associated with the material transformations. Also, you can see here why it's important to have like these other inputs like oxygen, so you really balance the CO2 emissions. Most of the fuels have like all the reactions, they are like available in book, so it's quite easy to estimate. And it's more like even if you use an ideal approach, it will not get too out, and you have like several coefficients available that you could kind of cross-check these estimations. And in terms of energy flows, So here you have like all the energy inputs, the quality of heat input, and also we try to specify how this is living the system, like if it's part of exhaust gases, radiation, convection of hot surfaces like furnaces, or is part of like the cooling of the material, and also like this minimum energy. So this for the chemical reactions. Right now we are referring to the Gibbs-free energy to manufacture the product. I just want to emphasize here that it still is one of the tricky ones. So like this accounts for the energy also used as coke. So like if you see here, like have like coke that is consumed as 2 megatons to reduce iron ore, but the equivalent of energy is also accounted here. So did you see that if you compare with other databases, you see like an overestimation because they don't declare the energy consumed as coke. But if you don't account for that, you see that when you calculate your energy metrics, you have a much more efficient process in place because you underestimate. So in summary here, like when you look to these resource flows, you can see that you have like mass balance, emissions balance, and energy balance. And also you can easily estimate such as like material yield, the recycled content of the material inputs, the CO2 intensity of the steel produced, the energy intensity, and also the energy efficiency. So this is like a picture for the UK for the year 2019. And like this is very straightforward, and all the information is there and you can cross-check. So I feel like it's a very important way to report. And this, while we are doing for the UK, could be easily implemented for a factory, for example, or even just one process line inside a factory. So just to show like the scalability of this, we could start to think in terms of like for the metal sectors. So in your case, like we select 3 main materials manufactured in the UK, that's aluminium, lead, and steel. So again, we implement the same approach, mapping the main material inputs. Something's going wrong here. The main material inputs and also the material outputs. So like here, I just want to mention that I did some grouping of the material inputs because you see like I just have like ores, but it's quite different. Bauxite from iron ore or even from lead ore when you process. I just grouped that to keep it simplified. And you can see like here all the materials, and then you start to see like slag and all other byproducts. So like I really try to emphasize like the amount of slag that it produces more than lead and aluminium combined. It's just because it still is the main metal that we produce in the UK. So also this material inputs and material output is always is kind of subjective. You can use different criteria, like we try to use a mass approach for to plot this. And here you can see again like how these exhaust gases, how the energy is leaving the system. I just want to mention that I use a color code. If you see a darker head, it implies that's a higher temperature, and a more clear head is like a lower temperature. So also it applies for the metals, and we can even look like combining all the 6 sectors. So like as part of the transfers, we mapped it like the 6 sectors, and for each of these sectors, we mapped it like the key products for them. For cement, it's just cement. For ceramics, we got these 4 broad categories is because of the data that was reported. For chemicals, how we are just looking to the bulk chemicals, these are the main ones. And also for glass, we map container, flattened filaments, and metals, as I just showed before, we got like these 3, aluminium, lead, and steel. Just to emphasize, like to have like a reference why we choose these 3 metals, we produce more metals in the UK, but if you check like steel, we manufacture around 7 megatons. Lead, we produce around 300 kilotons, and aluminium is around 200 kilotons. So these are the 3 main ones. When we start to think that 4th one will be nickel, and that one we just produce 35 kilotons. So like this is depends on like how much detail, how much time and workforce you have to map that, and then you see like where you want to set the threshold. And for paper also we got like these 4 main categories. So again, here, like you can see the same graphic, and I just want to emphasize that I mapped like the water flows for these sectors. I just scale it. I divided by 10 because if not, this graph will be pure water. So you can see that the most consumed material is water. So this is scaled by a factor of 10. Just keep in mind the numbers are right, just they scale the width of the flow. And again, here to keep it simple, like we grouped the materials, like to keep like minerals, recovered materials, and you have like also, I just want to emphasize, have like this difference between recovered materials and byproducts. So like these byproducts will be the equivalent of slag for steel production, like we use slag for the cement manufacturing. Recovered material is still scrap. So you get the scrap and reuse to manufacture steel. So like we make this differentiation. And you can see here that we group the material outputs not by product, but by sector. So you can see like the relative size of each sector in terms of products, byproducts, and all the emissions associated. And also it allows to estimate for us, like in terms of energy outputs, we also simplified in terms of what is really required. That's the minimum energy, heat losses, and what is recovered and sold. I just want to mention that this sold energy is just coming from the paper sector. Is the only sector that is really have like that sells energy in the UK. And again, here, like you could, we can estimate all the metrics if you just think for the entire industrial sector, not the entire, just the foundation industries in the UK. So this gives a perspective of the entire sector. And so like in summary, like you can see that this approach allows us to get like different boundary conditions and have the same Sankey diagram. So this also facilitates when you go to talk with politicians or people that are not in the field, because you always have the same graph showing the same information. Maybe you are changing the resolution just to simplify the graph, but the main information is here. And also you get consistent metrics. So like you can estimate the same metrics for all your boundary conditions. So you always have like the equivalent numbers that you can compare. So this is interesting to see, like when you start, if you just want to compare like material yield, you can see like for the steel is lower, for metals is higher, and like when you get for the foundation industries, it's even higher. So it's just interesting to see. You can have like different analysis on that. So this is part of like mapping the resource flows. So why we try to use this approach? Mostly because this allows us to get like the main metrics in terms of compatibility, like size from company to global scale, and also from time scale, like you can go from hourly to annual basis, really depending on the frequency of the data that you have available. And I think the most important is the transparency, because here all the data is reported and you can go there and cross-check, and you can see if the numbers make sense or not. Of course, when you are getting like combining for all the foundational industries, it's hard to cross-check. But once you get like for the steel sector, you can easily run checkings like to see if that data makes sense or not. One of the challenges of deploying this approach, define the relevant flows. Which criteria, for example, are mass or economic value? Because these, depending on the conditions, you can use different criteria. So in your case, we always use mass. And also one of the critical parts is of the omitted information, the technology associated and or the manufacturing process in place. For example, if you think in terms of steel, this is primary steel that's using a blast furnace, or you are talking about secondary steel that's using an electric arc furnace. And this is very critical if you want to evaluate or benchmark the metrics, the performance of the sector. So like the technology really needs to be in place, because different countries have like say different shares of primary and secondary steel. And it's hard if you get just one big picture for the steel sector, compare them across the board. So now just diving a little on this look of metrics, focusing on the performance industries, on the foundational industries. We have like this for the UK, like weighted at mean is a weighted mean for the sector on a mass basis, and scenarios for the UK. So best practice, that are in place for each of these sectors, assuming the same energy mix in place, and where the UK stands right now. And also we'll be showing the global average for reference. And also all this information is based for the year 2019. So you can see, like, in terms of energy intensity, you see, like, here is just getting the cement sector. I just want to emphasize that here is normalized for clinker output. That's the common unit that we use for the cement sector as a benchmark to compare performance. You can see that the UK is more energy intensive than the global average and could reduce around 20% if you deploy best practices of the sector. And you can see here that the UK is just more energy intensive in terms of the cement and chemical sectors. It's important to show that other sectors, ceramics didn't change too much, but for the glass and paper sector, we are performing better. But when you put like an overall metric and do the energy intensity and also mass associated, when you think as a sector, the UK is more energy intensive to deliver all the goods that we need for our society than the global average. And also we could reduce around 25% more if we adopt best practices. The same thing can be done for CO2 intensity. You can see that in terms of the UK, like, I think we just got the cement sector that's a little more carbon intensive than the other sectors. All the others are less carbon intensive. So one thing that's very important to keep in mind, that carbon metrics can hide poor energy performance, mostly if you have like a clean energy mix. So the UK has a relatively clean energy mix because we practically phased out coal and replaced with natural gas. This was back in the 90s. So even today, it's still a relatively clean mix. And you see, like, this energy intensive, while are not performing that great, we have like a better carbon intensity. So some of the remarks here is that I want to emphasize of this analysis, like in terms of best practices. Usually the best practices, they are based on surveys. They go to different companies and try to understand how they are manufacturing these goods. And most of them are outdated. Several of them with more than 10 years old. So it's still not critical because this industry has kind of like a great inertia that is not very disruptive, that things are changing year by year. So usually once one technology comes out, it takes a long time. Usually they just replace furnaces and things when they get to the end of lifespan. Another point in terms of boundaries, broad definitions can involve different things, and that makes really hard to make proper comparison. For example, when you are looking to the metal sectors of the UK, probably is not the same as the metal sector in China or in Vietnam or in Brazil or somewhere else. So like it's very different things that are manufactured. It still is one of the safes that we manufacture in almost every country, but the shares can change a lot. For example, glass is one that you see some countries that they manufacture much more high-end glasses. They have like much higher energy intensity for the glass sector. So it doesn't mean that they have poor performance. They are just providing more energy intensive goods. And also it's important to have, when you compare across sectors, they have different levels of development. And again, as I mentioned, like the share of materials can affect metrics if they are doing like more simple materials or more advanced energy intensive or material intensive goods. So yes, this work has a lot of collaboration from part of the Resource Efficiency Collective from Cambridge and also from other collaborators that are part of the Transfire. I think that's all from my side. Thank you all, guys.
Great. Thanks a lot, Nat. Right. So I'm going to leave room for a few more clarification questions before we move on to our next speaker. Maybe I'll start with one and then I'll turn to other people. But for example, Nat, you had metrics like material yield that you said would be useful to compare across industries. And the question is, how do you differentiate this result when companies have multiple products? How do you benchmark against that?
So That is tricky because if a company is manufacturing, let's say if I want to check the material yield of a company that's manufacturing different things, probably you need to get down to that process line. So assuming, let's just say given extreme example, the company is producing steel and aluminum, the same company. So you really need to go at the level that you have separation between them because these materials are quite different. And the same applies for other goods. So to get the most precise, you really need to go then for the process line of that good, or at least until assuming that you are having steel and some alloy steel, but until certain step of the manufacturing process is the same. So, and then you try to get the differentiation after that step.
Thanks. We have a question from Tong. Tong, do you want to ask it in person? And I saw one from them. Okay, I'll get to it.
Okay. So your research is very excellent. So I know the loss form to provide all the flow to calculate to calculate the final the final indicators for example, like CO2 intensity, energy intensity. So they have two questions. One about the time. So you should you calculate all the flow in the same year, or you collect the data from the different year? Also, how to use balance the time of the data you collected in the flow. And the second question is about the best practice. So I can see that the best practices in the scenario applied is also have very positive results compared to the UK and global. So, can you specify the best practice applied in your research? Can you see? Could you hear me clearly?
Yes. Yeah, I will try. If I miss any of the questions, so you ask or write again. I was kind of cutting for me. So in terms of the flows to be calculated in the same year, is not the case. So you try to adjust the flows because some sectors you get annual information, and as Rick mentioned, one of the big issues is omitted data. So sometimes even for the cement sector that I don't see that there is too much IP to be protected. That's a very simple process. You go to some of the databases of the government in the UK, and there is no energy flows associated. They are confidential. And then you go to the Cement Association, MPA, and they have all the energy flows reported. So, so sometimes you need to go to different sources and get that. One of the issues is in terms of to get everything in the same year is quite hard. Sometimes you see that are missing data that. One of the things that why we chose 2019 because was the year that have more data reported. So it would be interesting to go beyond, but I feel until 22 there is a lot of impact of COVID. So it's hard to get a real sense when things get back to normal. And 2019 is kind of the latest year. Maybe now 2023 we are back to normal, but not all the metrics are out. So we choose 2019 because of that. One of the things to adjust that is sometimes you are not going to have all your flows for the same year, and one of the things is try to make a correction. So if you see that everything increased by 3% from 2018 to 2019, and that flow that you are missing, you need to see if probably will increase by 3%. Or have some idea of how, for example, the energy flows increase with us increasing production, for example. So if you know that to increase 1 ton of cement output, you expect around 4 gigatons of energy extra. So sometimes you need to go for these fundamentals to to adjust that. It's really hard to get all the information for the same year.
Thanks.
Yeah.
Oh, sorry.
No, go ahead. I just finished that, yes.
Okay. Thanks. One question for Rick, actually. So, you also had different statistics that you combined together, and I guess you maybe had a similar thing with Nat, where you had to decide which one you trusted more. Can you tell us about the process of deciding that?
That's a good question. I think it doesn't actually happen as often as you might hope. So I think it's a good question in principle, but in practice, we're most often in the case where we've got 0 or 1 number to go on. I think other than that, ideally, if the data reports an uncertainty level, or you can estimate the actual uncertainty in the data, then that would be the theoretical answer, but that's also usually not the case. So I think what you're left with is the more qualitative methods, like I mentioned, the pedigree matrix that's used quite often for this kind of thing as a kind of data quality scoring. So that thinks about issues such as going back to the question of whether the data is for the same year. If you're using data from a different year, that might be one of the metrics that you score the data quality on. So you get a high score if it's from the correct year that you're interested in, and that would gradually reduce as it's from less specific years. And I guess also similar to other things that Nathaniel mentioned about the kind of technology. So if you're having to use some data that's for a similar process, or it's a bit vague about exactly what process it is, you might score that lower. And then there are ways of translating those kind of estimates into quantitative estimates of uncertainty, but I think those are quite not very well theoretically founded. So that's a difficult issue, I think, for modeling.
Thanks. So sorry. Just in the interest of time, I wanted to move on and save a few more remarks for later unless they're burning.
Yeah, so I just saw that there's another question here. The guys just asked about the backward flow. Just one thing, I didn't put like loops and backward flow.
He is currently coordinating the project that we have there, which focuses on material flows in the packaging industry. He's been working at InspireRay for a bit, where they focus on policies on sustainable consumption and production. Recently, they've been working on a circular economy policy. Tong has a Master of Engineering from Greenwich University, another Master's from National Economics University, and he has an undergrad from the Hanoi University of Science and Technology in Engineering. Tong, the floor is yours.
Okay, I'll open it. One moment. Can you see my screen?
Yes.
Okay. Thank you so much to have the opportunity to present. So all the experts have a very rich experience in develop the material flow. Firstly, so I can tell you that we still are learning how to apply the material flow, because as you know, the biggest challenge is for us and also to apply the material flow analysis is data collection. And when I have experience collect data from the UK, when I have 1 year learning master degree in UK. However, compared with the UK scenario, in Vietnam, it's very, very challenging for collect the data, because when we try to find any data, the data mostly are unavailable. They are not reported yearly. So as a result, we receive the funding from the CCZs and to do the material flows on the packaging industry in Vietnam. So a little bit about our project. And here's the objective. So we will try to analyze the status of material in the packaging industry. And we just have like around nearly 3 to 4 months to do this project, and it's under implementation. And that I can give you some background of this project and the reasons why we choose the packaging industry to do the MFA. So one, regarding some regulation and the policy regarding the circular economy in Vietnam. You can see here from the circular economy put in the law. So as we are like a policy maker, we try to develop the policy and for the Vietnam government, especially in the environmental policy. So we are develop some regulation regarding the circular economy. And here is the new regulation applied in Vietnam recently, especially in this year, is the EPR regulation. So under the EPR regulation, we have the mandatory recycling rate for packaging. You can see here, we have 4 types of the packaging have the mandatory recycling rate, including paper, plastic, metal, and glass. So follows on this regulation, we try to apply the MFA to track the flow of the packaging in Vietnam and to estimate this mandatory recycling, this the readiness and the feasibility for the enterprise to do the recycling rate, whether they can meet this rate in the near future. And here is the flow. This is a general diagram we try to input. We track from the resources, exploitation, production, consumption, disposal, recycle, and we track from the mining resources, materials, including the imports and export, for production, product, domestic consumption, and export, recycle. So to the waste collection and recycling. For the recycling, for the collection in Vietnam, we have the 2 types of the collection flow, including formal, informal, you see here. And the most challenging is stand in the informal sector because the data in this sector are not available. And is some roles of MFA model in Foster Circular Way. I can briefly move this. And this plan, so as we understand the challenges in the data, so we try to design the plan to do this project where we focus on the collect data. And so we apply to review. Firstly, we do some collect data by secondary document. So to apply the next study to collect data in the packaging industry. After that, we develop the questionnaire, identify survey subjects, and after we do some survey, we select 3 main objects to do the survey. Firstly, the management agency to have the general background of the industry. So after that, we do survey with the related industry association, because in Vietnam, the association they host of the many enterprise under the association. For example, we have Plastic Association, and they have around over 100 and 200 uh, packaging enterprise is a member of the association. So, and we also receive the support from the association to survey the enterprise to clearly understand the production process, how much the consumption, and collect the specific data. So, and after the collect data, we will do the MFA and figure out the solution and also appropriate policy for the Vietnam in the future. And step 5 is develop report, and also we'll organize a workshop in maybe in next month after we find the report here. So in the workshop next month, I would like to invite both of you to join, to participate in, and share with us your feedback and suggestions with our outputs of this project. And here, recent object I already mentioned, we follow the EPR regulation. We focus on 4 types of the packaging, including paper, plastic, metal, and glass. So at the moment, because because of limited time, so we did some survey, and here is a survey with the management agency, including we have the EPR office, National EPR office. We do a meeting to make a question and answer and collect data about the general background of the packaging in Vietnam. And here is a meeting between us and the paper association. So we have some general data. As you can see here, we collect the data from the paper association, and after this meeting, we continue collect the data from the enterprise in the paper packaging. So after the meeting with the paper association, we have some general data, and we initially draw a flow of the paper packaging industry in Vietnam, and this data we collected from this is updates the last data in 2024. It is first 6 months of the data, and we collect the data from the and there is a difference by the application to draw the flow between me and I try to apply the same thematic like you, but it is and because at the moment I'm not familiar with the schematic, so I use rather than I use a stand. So can you give me some comments and the feedback about the application I am using? I use a stand to draw flow, and because they can support me in the automatically calculate the flow. And you can see here this is paper, and we have the data from the forest domestic for the paper production and for the consumption and collection, recycle for waste, and we have the percentage of the recycle from the collection and return to the paper production for the next one. So this is very general because we have we just have the data from the association, and we still need to survey the paper enterprise to clearly understand the waste flow, which type of the material to produce the paper. And collection, what type of the paper packaging is the waste. So which party consumes the paper. But at the moment, we still have the general background, general diagram of the paper packaging in Vietnam. And after we are planning to visit the paper packaging enterprise in next week. So hopefully after this visiting, we can draw the more specific flows and show to all of you after next week. And here is the plastic packaging after we have collect data. Oh, sorry, it is still in Vietnamese. After we have the meeting with the Plastic Packaging Association, and we also apply the stand. We're going to draw the plastic packaging industry material flow. And here the difference with the paper. So that is the reasons why I asked you about the time, because you can see here the data I collected in 2023, but the data I collected from the paper packaging is from the 2020, the first 6 months of 2024. So there's the difference in the time. And when I'm thinking like to draw all the general all the diagram of all type of packaging is one diagram. There's difference between the time, the data you see here. I try to collect the data in 2024 from the plastic packaging, but they are not available at the moment. So that is the challenge that we are facing with. And so it is the plastic packaging in Vietnam, the collection, and the stream process collecting and recycling plastic waste. So the most challenging for the data we collected is from the informal plastic recycling, which is have like the dominant percentage of the collection plastic collection waste in Vietnam. But it is very difficult and challenging for not only our institute, but also for everyone try to collect data from the village. So villages, they call to recycle plastic. They call it from the informal plastic recycling. And so that is the reason why the most of the data from here we just estimate. Some data we need to do some estimation to calculate.
Sorry, Tong, 1 minute.
Okay.
Thanks.
And yeah, when we also visited the Glass Packaging Association in Vietnam to have some data, and that we just have the data from the production and production, and some data from volume, the material, and for the other data from the consumption and recycling, and we need to estimate. So here is some picture. We are trying to do the collect as much as the data as possible, and so this is a challenge in collect data. Police, they are not willing to provide data due to the confidentiality and competition in product and business. Data are not available at the national level. Because where we just have the data from the enterprise, but it is for the enterprise scale, but for the national level, we need to estimate. And it's also the difference between the data provided by different stakeholders. For example, like the data we collected from the government is different with the data we collect from the association, different with the data we have from some reports. And for next period implementation, we still do the conduct survey to collect the business data, and we will develop the report to clear all the challenges we are facing with. And also we will organize consultation workshop for after we complete everything. Okay, thank you very much. So that is my what we are doing right now.
Yeah. Thanks a lot, Tong. And this is actually opening the conversation now for the last few minutes of today for more questions. And actually, you've seen now the challenges of the different approaches and the methods. So I'm going to open the floor for some more questions. And if anyone has more, please write them down on the chat.
I have one question from what is the experience from the field? Because we understand that they can be very protectionist. And also, if you have any insights, if the government's taking position like to maybe replicate some of the practices that are present, for example, in the UK or in other countries.
John, would you like to answer this?
Okay. Sorry, Cesar, can you repeat the question, please?
How the companies are reacting when you approach to them? Like, I know they can be very protective, and the second is like how the government is reacting to that, because you see that you are pushing this forward, and there's not really national data available if they consider to replicate, for example, practices that are deployed in the UK.
Okay, for the first question, like we try. So I also mentioned about the challenge we face with when we try to collect data from the enterprise. For example, like firstly we develop the questionnaire and share to the list of the packaging enterprise in under the industry. But after we share around 100, 200, 300 questionnaire to the auditor, but just receive like 10 to 20 questionnaire. And the data, some of the data we need to confirmation by ask them the signature ask them to confirm their data they provide for us by the signature and stamp from the director of the company. But they still are not willing to sign and provide the stamp on the data as a questionnaire we share with them before, and some enterprise they provide the data for them, but the data just only like from their company. And then when we receive this data, we just need to estimate the data from the company scale to the bigger picture. So and now we are still thinking about what we should do, to draw a picture at the national scale. And for the government, as I mentioned about, we are doing the reasons why we are doing the project because of the new regulation regarding the mandatory recycling rate applies in Vietnam, and for the government they have the data. They have, because most of the company have responsibility to report their data to the Ministry of Environment. But when we have a meeting with them and asking for their support, they say to me that because we are doing the process doing projects. It's not under the assignment from the ministry, so it is difficult for them to provide data for us. So that is the reason we just have the data when to discuss, have the face-to-face discussion with the officer from the ministry. They could not officially provide data for us because they received the data from the company, and is it confidential and sensitive when they share the data from the company to us.
Yeah, thank you, Tong. Bringing up some more questions in the chat. We have a question from Rick about the process structure that is included in the stock in use for paper packaging. So essentially, I think, and Rick, feel free to come in, but identifying the different processes that occur and how you've structured that in the diagram.
Yeah, I don't know if that's a useful thing to talk about right now, but it was just if you, I don't know, do you want to show the paper picture again?
Me?
Yeah.
Yes.
Okay. Share screen data. Yeah. Here.
Yeah. I mean,
okay.
I'm not sure if it's, it might not really matter. It was just about, I was trying to figure out where you show the 335,000 stock.
300.
So you have paper production, and then that's the amount produced, and then you have that process is called paper consumption. And then maybe it's just the labels. I was just wondering whether it was useful to, whether there was multiple stages there, where there was some kind of production and then export before you get to the point where that is the paper that's being used. I guess I was just surprised that so much paper accumulated in use with that stock, because I'd assumed that most packaging was kind of went in and then it was used and then it was disposed of and recycled very quickly. So I don't know the answer, but that was just something that I was curious about, seeing whether you knew whether that was right, that so much paper is kind of accumulating and staying in use, or if maybe that represents just a difference between the amount that's accounted for and that paper is being used in other places and should be continuing down to the consumption and recycling.
The reasons is because I already mentioned to you, this data is collected from the first 6 months of the 2024. So because even like we produce like you can see here, nearly 200 million tons of the paper production, and the data consumes a little bit and still in the stock. The stock is around over 300,000 tons. The paper is the under stock, and we still they might be keep and sell put in the and for example, like after they selling the paper to the store, and the store still keep it and do not selling it to the consumer, and so it's still in the stock. And some of them is for the foreign export. You can see it's clearly, and for the consumption, that's been like this is already go to the like waste. They put is a collection and recycle, and I share. You can see a half for waste and a half for reuse and recycle. This is the estimation for the recycling waste and the paper go to the landfill here, and for the stock, and I for the stock here, because I collect this data is solid data, and this is solid. So that means like the number in the stock here is like the estimation after we calculate, applying the calculation when we have the solid data from the production and consumption. And the reasons I clarify to you that it's still under in the economic, it's still in the market and have not ready to consume by the consumer.
Thanks, Tung.
Right. Thank you.
I'm aware of time, so if people need to head off, please do. I might spend 5 more minutes if everyone is okay with this, with some questions. We have so there was a comment also from Rick around quantifying, or at least knowing uncertainty based on the data that we get from companies and the data that someone mentions, but we can't know if it's true because it's not related to their processes. I think this is a valuable thought that we can add to the analysis. And I guess we haven't quantified uncertainty there as such. So actually having those thoughts, Rick, were very useful at the start. Tong, would you add anything to that?
Data foundation. Yeah, it's okay for me.
Mm-hmm. All right. And then
I appreciate you've got a lot to start with just collecting the data in the first place. It's great to see how you're doing that and the results coming out. So I don't want to say you should be doing too much more, because I appreciate that must be difficult to get to this point. But I guess while you're going through the process of collecting data and talking to people, that's the easiest time to get their understanding of how confident they are. So it might be worth trying to collect that.
So one topic is very interesting in your presentation, Rich, is about the uncertainty of the data. So what we are thinking of how to estimate some data. For example, like the data we collected just only from the consumption and the exploitation. But when we check the flow of after we have the data from the production, now we need to check how many sector consume the packaging produces. For example, like especially the plastic, which is the most the highest amount of the volume in Vietnam, the plastic packaging. So we need to check which is the consumer. For example, like how much the mass going to the market, how much to go to the individual, for example. And it's still challenging for us to estimate like specific flow, and that's why I am thinking about the calculation and the formula to do some estimation, and need to have the clarification about the uncertainty of the data. And I can see in your presentation, you mentioned about the Monte Carlo, but formulation. So this is the first time for me to see this. Can you have talk a little bit about this to do some estimation about uncertainty data?
I guess I'd say there were two points maybe. I guess the first is in your current plan, if you're collecting data, I think it could be useful to try and collect what people think about the uncertainty in the numbers they're giving you. So like my examples, I think, are like if someone is saying we reckon collection rate is about 50%, that may well be the best number that you can get, so you should use it. But probably if you ask them how sure they are, they would probably say we don't really know, that's just our best guess.
Yes.
Whereas if the packaging association says our members produce so many thousand tons of paper, they're probably more confident about that because they can actually ask their members how much they produced, and their members will know how much they produced.
Yes.
So at the point that you're having those conversations and surveys, there might be some quite easy things to do to just kind of get an idea of whether this number is actually based on solid data or if it's just an estimate. And even if you don't do anything with that in the analysis straight away, at least you have that, and you can always improve the kind of analysis in the future. Then on the analysis itself, I think if you're using Stan, it does have some capability to use error propagation, so you can put a uncertainty on each number that you put in.
Yes.
So I think that would be the easiest way to start off maybe and see if that gives anything useful. But I mean, I think it's my point was probably mostly on the first one of those things, that even if you don't do that right now, because it does add more complexity and more to do, if there are some things that you can do to kind of think about that in the data that you're collecting, you'll at least have that available in the future if you want to improve the modeling of uncertainty.
Okay. Thank you very much.
Yeah, thanks a lot, Rick. One last thought from me before closing. If there's any, so thinking about the different processes that are standardized, and we've discussed between Rick and Nat how you take information from just like textbooks sometimes on how things work, and then can apply that to the material flows. I guess this is definitely an opportunity here as well. That will then lead to like improvements as more data becomes available. But I guess if there's anything that has come from your experience, Rick and Nat, that you want to share in terms of things that would be applicable to international contexts, anything is welcome.
I think one of the things that that sometimes can help to interact with industry is to show that one see that you can help them save money. And then, because if you get some of these key energy flows, like sometimes you not get enough information at the detail that you want for your process. But if you get just like this simple black box of inputs and outputs, and sometimes the most important thing is to know like the main material inputs, you don't need to know all of them, and all the energy and energy inputs probably need to know all of them. And you know what they are manufacturing, you just know the main final product. That is kind of like the enough information that you need. So instead of mapping like 20 or 100 of questions, you ask like 20 questions and like what are the most important materials and energy flow that you are consuming, and what are the material outputs. And with that, you are able to do this kind of estimations that you are looking, and also to look into metrics of performance. So you can have some idea of like if they are performing well or poorly performing, because these PATs, they are available from the European Union and the US mostly, so you can easily benchmark. So even they are not the most up-to-date, they are a good reference number. And sometimes you can go like to academic literature, like you put energy efficiency for paper manufacturing, for example, you find information on that. And I think this simplifies a lot your interaction with industry, and maybe can increase the success rate of interaction. I think that is one, because they get scared very easily.
Yeah. No, we've definitely encountered that. We had a longer questionnaire that had to be reduced because they just found it too hard to answer. So anyway, thanks so much. I know we're over time, but I just want to take a moment to say I really appreciate the time you've given us today to share the different levels of expertise. Like Tong said, we would be more than happy to have you, keep interacting with the project. And hopefully we'll produce something useful that can be taken forward. Thanks to the team as well, between ISPONRE and NEU, who's part of the project.
Yeah, it's great to hear what you've been doing. It looks great, and I hope some of what we talked about was useful for that. So thank you.
Thank you so much, Rich and Natal, and also to Carla, to set up a very informal and valuable meeting today. So after this meeting, I would like to still keep contact to both of you. And because every time we need to have some consultation from both of you and also Carla, and so we just have like 1 or 2 months left to have some initial reports, and also share with you to ask for your feedback and comments or what we reach, and for the MFAs also. And please, I will keep contact to all of you after this meeting. And also invite you any workshop or any events we organize by ISPONRE as well. And thank you so much to spending your time today.
Welcome.
Perfect.
All right.
See you
Bye.
all.